the cosine of pi over 2 plus a, which is this, is the opposite of sine of a, which is this. So cosine of a plus pi over 2 is minus sine a. So we can rewrite x of t as minus 2 sinc of t minus 2 times sine 2 pi 50 t. We know that the Fourier of sinc t is the rectangular pulse of f, and if we shift it by 2, it means multiplying the Fourier transform by e minus j 2 pi times 2 f. 2 pi times 2 is 4 pi, so that's minus j 4 pi f. That's for sinc of t minus 2. Multiply both sides by minus 2. What about the Fourier transform of sine 2 pi 50 t? Fourier of sine 2 pi at is 1 over 2j delta of f minus a, this number a, minus delta of f plus a. So the Fourier of 2 pi 50 t is 1 over 2j delta f minus 50 minus delta f plus 50. We have the Fourier transform of minus 2 sinc t minus 2, which is minus 2 pi of f e minus j 4 pi f is minus 2 pi f e minus j 4 pi f. And since x of t is this times this, right? It's a multiplication of these two. Its Fourier transform is the convolution of this and this. The convolution 1 over 2j delta f minus 50 minus 1 over 2j delta f plus 50 convolution with minus 2 pi of f times e minus j 4 pi f. Fourier transform of x of t, which is this mess, is, remember, the convolution of a signal with delta. It's the same signal shifted by a. X of t convolution with delta of t minus a equal x of t minus a. We have a bunch of deltas here. We multiply this by 1 over 2j. Minus 2 times 1 over j is minus 1 over j. Pi of f minus 50 times e minus j 4 pi of f minus 50. And we do the same for this term. This is plus, because minus 1 over 2j times minus 2 is 1 over j. Shift it to the left by an amount of 50. So pi of f plus 50 times e minus j 4 pi f plus 50. And that's it. The sinc of t is sine of pi t over pi t. And the graph of this function looks like this. It's 1 at 0 and it has this weird behavior. Now the Fourier transform of the sinc function is the rectangular pulse. I call it pi of f. Some people call it p1. Other people call it rect because it's a rectangular pulse. And it looks like this. From minus half to half, the signal is 1 and 0 otherwise. This is f. So pi of f is given by this. The rectangular pulse is the Fourier transform of sinc of t. We can now find the Fourier transform of x of t. We start with sinc of t, which Fourier transform is pi of f. Multiplying sinc by 3. If the Fourier transform of x of t is x of f, the Fourier transform of x of at is 1 over absolute value of a times x of f over a. So the Fourier transform of free sink of 5t is 3 times 1 over absolute of 5, the absolute of 5 is 5, times the Fourier transform of free sink of t, which is 3 pi of f. Thus the Fourier of free sink of 5t is 3 times 1 over absolute of 5 times pi of f over 5. But the signal x of t is free sink of 5t minus 13, and this can be written as 5 bracket t minus 13 over 5 close bracket. So the Fourier transform of x of t is 3 over 5 pi of f over 5. This times exponential of minus j 2 pi 13 over 5. If a signal x of t has a Fourier transform capital X of f, then the Fourier transform of x of t minus a is capital X of f times e to minus j 2 pi a.